All right. Hello, hello, hello. Welcome to Intro to Cybersecurity Machine Learning Applications. I am Tiffany Webb, and I am your host today. I am not a technical person. However, we have Joseph here who will be as technical with you as possible. I am here to help, watch the chat. If you guys have questions, please feel free to throw them in the chat and we'll try to get around to all of them. If you are using the chat, make sure to click on the to button and there's a little blue bar. You want to make sure that you choose everyone. We want everyone to see your questions so that they can see if they have similar questions or they can learn alongside you. I will pass the course over to Joseph, who will be going through a deck with you. We will share that deck at the end of the event through the email that you will get. So no worries, you will get all the work, you will get the recording if you ever want to watch it back. But in the meantime, let me pass it over to Joseph, who will be your wonderful instructor this evening.
Thank you, Tiffany. I appreciate that very, very much. Welcome to everyone tonight. Looks like we have a great turnout and lots of good TV advice, which I can always use too. So, because I'm always like 5 years behind whatever everybody's watching. So,
same.
So again, this is cybersecurity and machine learning, or as I entitled it, really cybersecurity and big data. A little bit about me, real quick. I've been teaching at the Flatiron School since the spring of this year, but by training, I am a licensed New York State attorney. Been one for nearly 20 years. I'm located in Rochester, New York, not far from Buffalo and Toronto. I'm by trade and experience a labor and employment lawyer. So what am I doing here? I'm also a lifelong nerd. I've been programming and into technology for forever. I'm a big gamer and that sort of thing. And a few years ago, decided I wanted to pivot back into technology and see where that took me. Went back to school for my second master's degree here in Rochester, and have been teaching at a couple different universities and here at Flatiron, which I love as an organization. So that's basically me in a nutshell. Not that I'm all that interested. Let me share this deck and we'll get going. If you have any questions, please post them to the chat, and Tiffany may select a few to shout out, or we can talk about them afterwards. So essentially what we're going to do here is go through in a loose format my slide deck. Can you see that, Tiffany? Just want to make sure.
Yes, it is up and running.
Excellent. And my talk is my entire presentation here tonight is going to be broken down into about 3 pieces. My talk here is 2 parts of that. One, really talking about cybersecurity and data itself and why that's a problem and what that really means. And then the second part of that is focusing a little bit more on machine learning. This is not a technical talk at all. Machine learning is a very deep and technical aspect of information technology and outside the scope of what we're talking about here. But the good news for those of us who aren't into the nitty-gritty of programming and all of that stuff, you can harness machine learning any day without being a data scientist. And cybersecurity folks do that all the time. The third part of this will be Q&A afterwards. If you have any questions, I'll be here hanging out with Tiffany, and any questions you have about cyber or Flatiron or pretty much anything, we're open to talk about. Real quick, everybody's here. It's great to see so many people signed up and excited about this particular topic. Flatiron, right now, we have 4 programs just to back you up. We're going to be talking about cybersecurity and a very specific piece of that. But there's cybersecurity, there's data science, there's computer engineering, and there's design as well. So a well-rounded aspect of Flatiron is that there are other programs too that complement what we do in cyber. It's a nice range of things. If you're here not totally bought into cybersecurity yet, there are other programs to explore as well. Lots of great opportunity in every one of those. So as I say, cybersecurity is big data. What does that really mean? Well, let's back up. What is cybersecurity? Why do we even talk about cybersecurity at all? I think, it's hard to, open up, a news site, your phone or anything else nowadays without hearing about cybersecurity. It's all over the place, all in the news, all the time. We hear about it all the time. What does it really, really mean? To get a foothold into it, what we're really talking about is really three different things: confidentiality, integrity, and availability. What we call the CIA triad, not Central Intelligence Agency, but confidentiality, integrity, and availability. All of cybersecurity reaches back to those three pillars and those three concepts that sort of interlock to deal with our digital security world. Okay. And then specifically what we're talking about is, identifying, resisting, and addressing attacks and threats, and taking defensive measures through all sorts of technologies and processes and controls, all sorts of different things to keep us safe online and in our digital world. Let's take a quicker look at confidentiality, integrity, and availability. What does that mean? Confidentiality, secrets, keeping your stuff secret, whether it's your stuff, whether it's your kids' stuff, whether it's your company's stuff, your employer's stuff, whatever information is important to you. Maybe it's your banking stuff, maybe it's your pictures online, maybe it's your social security number, any number of things. And any one of us would probably be surprised that I go through a long exercise at the beginning of our cybersecurity program where we really drill into all the possible things you can find on someone's smartphone. And it is amazing once you really think about all the stuff we carry around in these little supercomputers in our pockets. Lots and lots of secret stuff that we probably wouldn't want to share just easily. Most people can come up with 5 or 6 things. I can easily list for you 50 or 60 very specific things that all of us carry around on our phones that we are like, wow, that's there too? Yeah, lots and lots of stuff. We want to keep that stuff secret. We want to keep it confidential. That's that part. Another thing that a lot of people don't think about so much is integrity. What does integrity mean? Integrity means essentially accuracy. Can we trust the data? Not just keep it secret, but once we've shared it or sold it or used it, is it accurate? When you store something somewhere, whether it's a photograph, whether it's a document, whether it's a database, whatever it is it susceptible or safe from somebody messing with it in some way? And then finally, availability, making sure that systems are always available. Quick story that literally just came to mind. This last Tuesday morning, I got, well, actually, that's not even true. Monday night, the entire internet in my entire region of Western New York went down, which is pretty, unusual. And that lasted all night and into the morning. And I had to literally run my class here off of a hotspot off my phone. The point is that we're not used to that, right? When the internet goes down, when availability goes down, when systems go down, it's not unusual maybe for one website to go down for a few minutes, but for, a third of a state to go down is kind of a big deal. So those are the 3 things we really, really worry about: secrecy, accuracy, and just making sure everything is available when we want it so that we can get to our stuff. But one of the things that people don't realize is how much data we're talking about. If you have, a basic cell phone, you've got tons and tons of storage space. You're carrying around, your probably years worth of photographs and videos and all sorts of stuff in your pocket all the time. That's just one of you or me or us or whoever. Once you multiply that out against all the people in our country, in the world, all of the different devices that are around us all the time, constantly transmitting data, you really start to realize that cybersecurity is nothing but big data. Okay, what does that really, really mean? It means that we have a proliferation of systems, networks, devices, accounts, all sorts of stuff. If you're like most people, you probably lost track a long time ago about how many passwords you have, all the accounts you have, all the different things you have online, all the devices you have. And all those things are constantly, even if you're not conscious of it, creating, sharing, connecting to networks and sharing data. On top of that, because there's so much, there's actually different vectors of data. We call them the 5 V's. Velocity. Data nowadays is moving at a speed it barely moved 5 years or 10 years or so ago. And now it's just moving at an incredible rate. Variety, the more devices there are, the more kinds of devices there are, and the more that proliferates, just multiplies things out. The sheer volume, and I'm going to show you some examples here of what we're talking about to really give you an idea of what we're really dealing with, is just almost incomprehensible today, and it's only getting bigger. Veracity, the truth of data, how reliable can data be? And then the value, more and more, if you read in the media about what data is money. Cryptocurrency is money. Your particular information and your account information and all sorts of things is of value to the big corporations like Amazon and Google and everybody else. So the big 5 V's, those are the things we talk about. That's in terms of giving some perspective to what data actually is. How big is big? Here's one example. One autonomous car can generate 100 terabytes of data in a year just driving around. So 100 terabytes, for those of you who are less technologically savvy, it's not uncommon for a basic laptop to have maybe half a terabyte of storage on its hard drive, maybe a terabyte. So think about it. If you had 100 laptops stacked up, that would be enough storage you need that much storage to store the amount of data that an autonomous car generates and transmits while it's doing its business out on the road. Some other examples.
I'm sorry to interrupt, Joseph. There's a quick question. Is that for older or newer computer-based cars?
Specifically, that was for autonomous cars. Yeah.
Gotcha.
So that specific example was for one generic example for an autonomous car. So that's more like a self-driving car that you hop into. Those are still pretty rare. Now, the thing about when we talk about data is that it's like a spectrum, right? I have a middle of the road SUV sitting in my, driveway that has a data connection, and I, play Spotify on it, and whatever else it transmits. But doesn't need to be internet connected. But like a Tesla, that comes with a data connection, and the data is sort of part of the whole experience of a Tesla. A Tesla generates many gigabytes of data a day, even though you're doing the actual driving. And then once you get to an autonomous car that's talking out to the internet and gathering information and transmitting information, that's that much more data. You see what I'm saying? It's like a spectrum. Different vehicles will transmit and create different amounts of data. So here's a few other examples. In 2020, it was estimated that individuals generated about 1.7 megabytes of data a second. 1.7 megabytes is a pretty decent sized photograph file, for example. Imagine that you're creating enough data every second to take a picture every second. That's enough data for all of us. In 2022, it's estimated 70% of the world's GDP will have experienced digitization. Last year, 68% of Instagram users were provided photographs from some sort of manufacturer. Images being pumped out towards us all the time. In a few years, 200 plus zettabytes of information are going to be in cloud storage around the world. In 2020, users shipped around 500,000 tweets a day. At the end of 2020, 44 zettabytes will compose the whole digital world. And every day, 306 or so billion emails are sent and 500 million tweets are made. So that's just some barest broad statistics to give you an idea of what's flying around us all the time, whether it's wired or wireless. And it's everywhere. For example, the Internet of Things. I have a smart dishwasher now, and I'm not really quite sure why, but it's true. It's internet connected, and I can start it and I can stop it. And I've got plenty of other internet connected things. All those devices that we start to take for granted, we just bring into our homes, throw them on the Wi-Fi. I think I lost track of how many IoT devices I had at around 40. I just have way too many toys and way too many tools. So just those sorts of things are constantly moving data, and they actually pose a security risk potentially to ourselves, to our families, to our homes, to our businesses, and we need to track and deal with all of those. But there's also traditional systems. Before anybody was talking about IoT, Internet of Things, and all that stuff, there was the boring stuff we take for granted, like routers and switches and servers, Wi-Fi transmitters, all sorts of different devices. And this is just sort of a sample of different network and computing terms. But this is just the sort of stuff that even 25 years ago, if someone looked at this list, we go like, oh, those are pretty familiar things. But that's what our network and our life rides on now, and all of that has to be protected. On top of that, so that would be tough to keep on top of, even if there weren't threats, even if there weren't people or organizations or nation states trying to do bad things. Okay, we're up until just this moment, I've just been talking about this massive data that's very difficult to keep track of. Well, on top of that is we have people trying to do bad things to each other on top of that. And so, for example, before 2010, the security community was aware of roughly 50 million different pieces of executable software or malware available out there to do something bad. That doubled by 2012, and then that was multiplied by about 20 by about 10 years later. So close to a billion different pieces of malware are considered known at this particular point. So between all the software that's out there trying to do bad things, the organizations and people trying to use the software against law-abiding citizens and organizations and nation states, and just the sheer volume of stuff, you realize we got a big problem. We got a lot of stuff that we got to handle. And the way we do that is we use software. We throw more software at stuff, and software meaning what's called security incident and event management platforms, SIEMs, SIEM. And there are a number of companies that create these and provide these platforms. Well, what they allow us to do are these massive software packages that teams of people use 24/7 around the world to do things like collect information and track information out of all that data, do all sorts of forensics with that information, analyze that information in real time and in historical perspective, audit information to understand how to make things more secure over time, gather intelligence on future threats or vulnerabilities in our systems, monitor and respond to alarms on our systems, operate 24/7, 365 security operations centers, and respond to incidents in real time. If anything, the list here that I just read off is the traditional activities of cybersecurity specialists. But when you start talking about the amount of data and the velocity, the volume, the value of it, and the fact that no one person or even team of people could possibly stay on top of it themselves, that's where machine learning comes in. Artificial intelligence, deep learning, all baked into these software packages we call SIEMs. And that's what I'm going to spend a lot of time here talking about, because You may have heard a few of the brand names I'm about to mention, but most people have no idea about what these things actually do. And I think it's fascinating that these systems exist. So going back nearly 30 years, though, let's talk about a little bit of history here. I promise I'll only do this for one slide, so people will stay online with me here. But if you know your internet history, or if you don't, you might be surprised that the first web browser was released to the public in 1993, almost 30 years ago, 29 years ago this year. And the first couple of years, people were interested, but it wasn't that big a deal. But pretty soon, things started to multiply. And by the mid-90s, people realized, even back then, there was more data than humans could possibly deal with at any one particular point. So this idea of SIEMs came to be, these platforms for monitoring networks, dealing with networks, and starting to look at the security issues that were starting even then to become a thing. As more, the more the internet became popular, the more commerce became a thing online. The internet bubble of the late 90s was growing. And people realized that we needed to deal with security in a much more organized way. And so, for example, in 2000, a famous SIEM called ArcSight was started. In 2001, QRadar was started. That is a software suite and platform that IBM runs today. Logarithm and Splunk started a couple years later. Splunk is a big deal. I'm going to focus on that a little bit later, and a few others. Microsoft has Microsoft Sentinel, and there's others. The point is that without these platforms enabling us to harness machine learning and artificial intelligence, there's no way we could possibly deal with the cybersecurity challenge of confidentiality and integrity and availability. So what do these SIEM platforms do? Well, they bring order from chaos, essentially. Okay, everything from recording the data and the patterns of data that go through a router on a network, to what's happening on a particular server, to what's happening in a particular server farm, all sorts of stuff. This illustration here sort of brings the puzzle pieces together, if you will, with just a few examples, but obviously there's thousands more. Firewalls, servers, routers, workstations, all sorts of things, disparate sources of information, of network flows and information flows that we can analyze using machine learning and artificial intelligence inside the package of a SIEM to bring order out of the puzzle. And it's all about pattern matching in the end. Machine learning is amazing technology, but at its heart, it's all about patterns. Machine learning works because we can teach a machine to recognize patterns, and then to recognize patterns within patterns and continue on. So that's why machine learning actually exists. And even before machine learning started to be a thing in SIEMs were all about pattern matching. We're going to get into that in some more detail later. But again, I covered some of these activities before the previous slide, but things like forensics and monitoring and alerting and responding to incidents, that's what SIEMs do. Every large, small, or medium-sized cybersecurity company at its heart has some suite of software that allows us to engage in all of these different, very important but overlapping and related activities. Another thing to remember, and this is a bit of a sidestep from the main story here, is that cybersecurity isn't one thing. Every cybersecurity incident, everything that is happening at any point in time is actually on a spectrum. There's sort of a life cycle. And so, for example, this is the barest idea of that, an illustration of that, where on the left side, we start with simply forensic data, lots of data that we can use our SIEM to search through and see if anything bad happened, or if we become aware of something bad happening, looking back to find evidence that allows us to analyze the situation. We can also discover data and then also qualify data. What does that mean? Just simply, if you think about all this data, most of it, 99.99999% of it being utterly normal, we're always looking for that one tiny little blip that makes things different. And again, that's when something falls out of pattern. What SIEMs do is record and detect patterns so that we can see when things are out of pattern and are therefore unusual, and set off alarms that we respond to. If something goes bad, that's sort of the detection phase. But once something goes bad, hopefully we respond, we get notified of it through any number of different tools embedded in our SIEM, and then we can respond. We investigate in the shortest instance. Once we find out what's going on, we can neutralize problems, and then ultimately, hopefully, recover from problems, putting systems back online, regenerating data that was lost, recovering money or other information that was lost, and so forth. So you see kind of a life cycle here, that there's different points along the spectrum of any particular incident. And it's important to note this for any of you that is here exploring a career in cybersecurity, that, I'm only about maybe halfway through my slide deck, but there's lots and lots of opportunity. I've mentioned lots of different things. Data, big data. That data sits in databases that are inside SIEMs. Databasing is its own profession, lots of opportunity there. Each one of these points on this particular timeline is a very specific specialty. You don't have to specialize, but there's all sorts of things people get into, like the forensics piece of it, the evidence piece of it, the legal piece of it. All of that stuff is on this spectrum. Recovering and incidents response, all of that stuff. So lots of different opportunities that mesh with different people's personality types, different people's interests and talents. Cybersecurity isn't just one thing. That's why, to me, it's one of the most exciting things there is going, because there's so much opportunity within the field for all sorts of different people, no matter how they, come at this, what experience they come at with this with, how, what their particular interests and identifications are. There's probably a place for you somewhere in the cybersecurity world. So specifically what we do is we use SIEM platforms as a force multiplier. Essentially, we use the machine learning and databasing power of a SIEM and the organizational power of a SIEM to extend what we can do as people. We work in teams to try to basically understand this massive information, to find what's going wrong and fix it. And the way we do that is we use SIEMs to extend our visibility into that mass of data that we've been talking about, to place ourselves within the data to understand what the flow is and what is happening. So that's the context. If I know that something originated in such and such place, or such and such machine, or with such and such account, that gives me a starting point from which to investigate further, to get evidence for a legal action, or to simply stop something, or to continue investigating and hound it down to its source. Lots of different things that context is important to.
Joseph, again, we have a question. I'm sorry, we have a question in the chat from Dan. Yeah. How are SIEM platforms monitored, supervised, and controlled?
Well, essentially, our robot overlords take care of all that for us. No, I'm just kidding. There are no robot overlords that I know of. You almost wish there were, though. The thing about it is, that's actually an incredibly good question. Let me quickly slip back to the very first slide. So up here at the very top of the first slide is a photograph of IBM Security's QRadar cyber range. Okay, this looks like a still out of a movie, right? We've seen this sort of setting I don't know how many times in how many movies or TV shows where there's hackers and stuff like that, big screens on walls and people in low rows of computers. These places really exist, okay? And IBM pioneered this idea of a cyber range where you bring all sorts of experts together in one room or a series of rooms where they can communicate together in real time and share information on these massive wall screens. So IBM pioneered this idea of a cyber range, basically a control center, otherwise sometimes referred to as a security operations center, where all this information is funneled in and you can visualize, sort, and share information in real time with people. Now, obviously, after COVID, I'm pretty sure this was a pre-COVID photograph, how cyber ranges and SOCs work and all that stuff and how people relate to each other in teams is different. People work a lot more dispersed now. I'm sure a lot of people are going back to live ranges now too. But the short answer to your question is yeah, people sit in front of computers, as we say, eyes on glass and hands on keyboards, looking at information, looking at gauges and dials and flows of information. I have some more detailed photographs. But essentially, yeah, working in live teams, communicating together, cooperating together, watching stuff like security guards in any sort of other sort of security center. Our security world just happens to be online. Does that answer the question?
I think so. And then there's just one more question about SIEM platforms. Carl says, I'm curious whether modern SIEM platforms detect, report, and or patch new undiscovered vulnerabilities.
Yeah, that's a really good one. Which actually brings me to my next slide.
Look at that.
I know, it's like he was planted there. So, no, really good question, because the question, this idea of undetected threats and things like that, that's what we call a 0-day vulnerability. 0-day meaning something that's never seen the light of the day and has been taken advantage of by a bad actor. The problem with that is because you haven't seen it before, you don't know it's coming. So how do you deal with something that you've never seen before? Back to patterns. If one of the things that SIEMs do in order to detect things like 0-day vulnerabilities and attacks, things that are completely out of the blue that you've never seen before, is to fingerprint network traffic, fingerprint software, fingerprint activities across the entire enterprise that they're plugged into. When you have this massive data and everything is flowing absolutely normally within certain parameters, you can basically, like I said, fingerprint your network. When all of a sudden something goes haywire, you have a blip of traffic where data is now far exceeding what it normally would from a particular device or a particular place or a particular network, you can kind of go, well, maybe something isn't wrong, maybe something's just broken, but that zooms you into that particular thing and gets your attention, and alarms go off, and the people that run the SIEMs pay attention and hop online and go, okay, well, this server farm over here is all of a sudden gone haywire, or maybe it's gone offline, the opposite, just gone dead. You never know. So we're looking for one of the things that really important things that SIEMs do is pattern matching, fingerprinting the environment that they're related to, so that when anything happens out of the ordinary, the operators are alerted, and then their attention is diverted into that particular situation so they can respond to it. But that's really exactly where my slide is, because here's the thing. We have two different pictures that at a glance look quite similar, but they're very different. We have a needle in a small pile of straw or hay, and we have a massive needle in a big bale of hay. With two needles, but they're two different things. The point here is perspective. Sometimes the thing you're looking for is the tiniest thing. It can be literally one packet of data that's off for some reason that the SIEM helps us detect or find after the fact that leads us to other information. or it could be a massive thing like a data center going down, going blank for no good reason that stands out like a sore thumb. SIMs let us look at both things simultaneously, the forest and the trees, if you will, the tiniest detail and the massive data all at the same time. The other thing that SIMs let us do is search. When we know that there's something wrong, we need to find it. They're very powerful in allowing us to use machine learning and plain language searching to zoom in on things that matter towards detecting or responding to a particular attack or risk. This is sort of an illustration, just a sample screenshot of what SIM traffic looks like on a particular screen on somebody's particular dashboard in a security operations center. Like most security, most surveillance, if you think about traditional security, your security guard walking the property of a particular location, someone sitting in a security booth monitoring video cameras and that sort of thing. SIMs do the same thing, and people sitting in SOCs do the same sort of thing, watching traffic go along and seeing how they relate to each other and seeing what's different. In this particular case, for example, at the very bottom, again, this is just an example shot, but at the very bottom of this slide, you see a spike, and on either side of that spike, a trough. Right there, we have traffic falling down to zero from what looks to be a normal amount of traffic, then spiking really high to 100 megabits per second, and then dropping off and then hitting normal again. That may be perfectly normal, or it may be completely out of the ordinary. Who knows? The point is these sorts of visualizations are what analysts use in order to quickly understand masses of data. Each one of these graphs could represent terabytes worth of information, but at a glance, a skilled and experienced analyst sitting in a SOC or working from home nowadays might be able to look at something like this and go, oh, wait, there's something really bad happening here, or that's no big deal, I've seen it 1,000 times. More visualizations, all sorts of graphs, all sorts of software that allows us to analyze and understand information in a way that makes sense. This is just the logos of a few of the heavy hitters. You may have heard of the company Splunk, Microsoft's Azure Sentinel software, and IBM QRadar, which I've already mentioned. Splunk is a very big company nowadays. It's in terms of valuation on a par with the biggest IT companies in the world. Does not consider itself, just like Microsoft or IBM, a security company. The Splunk SIEM, which everybody just refers to as Splunk, is really a small subset of its machine learning data management and suite of software. So really, Splunk is a data company, and cybersecurity, as big as that is a small subset of what Splunk really does. But what I like about Splunk, just out of curiosity, aside from the fact that it's got a fun name, is that they also do cool stuff like sponsor the McLaren Formula One car, because a few years ago, actually this happened over the pandemic, everybody was working from home and they realized how much data flows through a Formula One car because they're all playing online. And they decided, hey, we should sponsor one of those cars and also help harness the data that flows through it in order to make the car better. So lots of interesting stuff. I mean, that's the thing is, until you start thinking about it, you just don't realize how much data is everywhere. A Formula One car is pumping out gigabytes of data as it goes around a track through thousands of sensors throughout its entire vehicle, and it's just amazing what they can do nowadays.
Joseph, we have a quick question, but also I love the Formula One car you showed. Let's go Lando Norris. With an estimated 16,000 code changes per day within Google alone, how does SIM spot what is normal and what isn't?
Oh, that's really good. Yeah, that's again, um, it's about pattern matching. Code changes are different because those are in the normal course of business. If you think about the ocean of data that I've described at the beginning of this talk, um, you have waves and swells in a given body of water, and things are going to um, look pretty much normal if you're standing at the shore. But throw a rock into the middle of that lake or ocean or that sort of stuff, and all of a sudden you have a set of ripples that are out of the ordinary, even amongst the waves and swells and ripples. And again, getting into the deep pattern matching and the mathematics of machine learning is out of scope for our talk here. The point here, though, is that the algorithms built into machine learning software within the SIMs look for those anomalies even when they're really, really tiny. And the normal flow of data and code looks very, very normal to the SIM until something very small happens and it detects that change. But again, it really boils down to the humans that are involved to make the judgment call of whether that particular change from the fingerprint is legal or illegal, bad or not bad. What's it affect? What's its effect? You know what I'm saying? So
I was one more question from Robert. Wouldn't hackers know all of this information and these tools as well? How would you guard against attacks that don't have any patterns, maybe by sending analysts in the wrong direction?
Right. These are fantastic questions and something that we talk about in our program a great deal. And they talk about in other cybersecurity educational programs as well. Yeah. I mean, whether you're talking about a lone wolf with a VPN connection and a laptop somewhere in the world, just wreaking havoc, or a nation state actor like Russia or Iran using all of their resources to cause havoc on a much wider scale, it is very difficult. One thing I will say, job security. The fact of the matter is because there's always bad guys, they're always going to need good guys. And if you look at how many jobs there are out there somehow connected to cybersecurity right now, it really sort of depends on where you like to put your cutoffs. As far as just simply cybersecurity analyst jobs, folks like in this photograph, hanging out in a SIM, working on day-to-day cybersecurity stuff, there's hundreds of thousands of open positions and opportunities. Beyond that, in terms of sales and marketing and human resources and everything it takes to support these people, there's hundreds of thousands of more jobs. Beyond that sphere, the legal world, the policy world, the law enforcement world, there's just so much. Yeah, but back to the question, how do you detect stuff? When things are definitely out of pattern, then there's a problem. And that's why we have these systems, in order to help us detect those things. Just like having, for example, a fire alarm or a motion detector in your house. You don't know what's going to burn in your house, but once it starts burning, you want there to be some sort of detection system. And that's basically how SIMs work in the broadest strokes. Okay. There was another question here I saw in the chat. There's a lot of good flow in the chat tonight.
Yes, thank you all for adding such great questions for Joseph to go over. Did you see the one that I may have missed, Joseph?
There was one that caught my eye and came and went. There was, wow, yeah. So Dan posted impressive platforms, but in the vital process of cybersecurity, where does the buck stop? Who do we ultimately rely on to ensure our collective safety? The government, business? those are great policy questions that we talk about in our classes as well. If one of the topics that, so cyber, to back up a little bit to our program a little bit, our cybersecurity program is broken down into 8 topic areas, plus a 9th one, which is really our final project for our full-time program. And most of those are very technically related, application security, cryptography, network security, and that sort of thing. But there are a couple. One is threat intelligence, and the other one is called GRC, or governance, risk, and compliance, that frankly, the more technically oriented folks tend to stay away from. But what I'm here to tell you is that there's a ton of opportunity there. Governance, risk, and compliance, those 3 words don't usually get most people out of bed. But really, that's really where a lot of opportunity is for careers, because that's where leadership and management is for all of this stuff. So a lot of our folks first approach GRC as like, are you kidding? We're going to talk about how corporations are formed? Yes, we are. We're going to talk about how corporations are run and how decisions are made and how policies are written. Oh yeah, we're going to do that too. Because none of that stuff, none of all this cool stuff like it's in the screen here exists without the leadership of enterprises and governments and organizations making decisions on how to provision for security. Somebody's got to decide what is important, what money needs to be spent on what and where, who to hire, who to train, what to focus on. And so when we get back to where the buck stops, it really depends on the scope of what you're talking about. Ultimately, in the United States, because of the way our society generally runs, we believe in self-determination. So the way we work cybersecurity in the United States is pretty much on a enterprise to enterprise basis, and a person to person basis. If you decide not to put a pin on your phone and use multi-factor authentication and you leave it wide open and somebody swipes it, hey, that's your problem. If you have a multi-million-dollar business and you decide not to have robust security and you decide not to buy insurance and everything goes haywire for you one day, that's your problem. In Europe, they face that problem differently. For example, the GDPR privacy regulations, their mandate a variety of different protections for people in a very proactive way that is so powerful that essentially it forces American businesses and American governments to follow European rules. So, there's philosophical questions there, great questions about where the buck stops. In the United States, generally speaking, it's with you or the owner of a particular business. Is a short answer to that question. So I'm loving these questions. This is great stuff.
Yeah, they're great. Well, there's a few more, but if you wanna push through a little bit and then we can ask them at the end, but it's up to you really.
Yeah. So, well, the one that just popped at the very bottom, and I wasn't going to go here, but I'm going to go here now. Do you guys talk about cyber insurance? Yes. And see, so that's another layer of protection where when all else fails, just like with your car or your health or your house, you want to make sure you're insured. And so the idea of having cyber insurance on your enterprise, on your data and all that stuff is very much front and center. But really, it's sort of a 3rd tier protection. You want to be protected right up front, so that an incident is either completely avoided or minimized from the beginning. Interestingly enough, the insurance industry in the United States, especially and around the world, is probably the major driver now for cybersecurity quality across businesses and enterprise. 10 or 15 years ago, cybersecurity insurance companies had no what they call experience with this stuff and were vastly undervaluing claims and not charging enough. Now it's really hard or expensive to get cyber insurance, but before a cyber insurance company will bind you to a new policy, they're going to make sure you've got all the bells and whistles to reduce their risk. So it's a lot of stuff to consider, but that's a great question. So a few more slides here. I know we're getting towards the top of the hour, and it sounds like we're going to have a great conversation. So again, what makes all that stuff work? What makes all the people, in here work together? It's what makes this car optimize what it's doing around this racetrack? It's machine learning, and it's artificial intelligence that is harnessed behind the scenes. Real quick, again, this is not meant to be a technical machine learning or AI talk, but just to give you some basic ideas here. The big umbrella term is really artificial intelligence, the idea that we use machines to somehow simulate some sort of decision making that is somehow human-like. The more human-like it is, the more uncanny it gets, the more we call it artificial intelligence. Machine learning is the idea where we go from there, where it's just where the software is proactive, where it literally starts to learn on its own. And the way that does it is by being fed patterns to then find other patterns and then to build upon that. Then finally, there's deep learning, which takes all of those ideas and sort of really kicks it into gear on a very, very fine-grained level that without which these systems just wouldn't run. Machine learning boils down to two different kinds: supervised learning, where we feed models of data into systems and then have them comb through masses of data to classify information into different types and silos in order to make decisions. And then unsupervised learnings, where we unleash neural networks to write their own algorithms to identify patterns that we ourselves can't even see. That's the real secret sauce here. This idea that there are patterns in data that we can't even conceive of, but we're developing software that can. And classification simply being the idea that we have a training data set that then allows us to create software that then finds new patterns within a mass of data. I see there's probably a few programmers in here from what I'm seeing in the commentary, or people who've had at least some programming experience. In our program, we do focus, one of our topic tracks within cyber is Python programming, not to any great depth. Again, we have an entire course or entire program of software engineering that uses a variety of different languages. Python is very popular because in cyber, because it's easy to learn. It has many robust libraries of software that are already available to do a variety of different things that you want to do. But our program focuses on Python and the Python libraries that focus on data analytics. And that's everywhere from simple pattern matching that does not involve AI or machine learning to full-on AI and machine learning, visualization, analytics, web development, scripting, boring tasks, scripting important tasks, and everything else in between. So we do a deep dive into Python, enough to do some pretty serious scripting and some basic application development. And so, for example, Python libraries and Python code can be used to visualize data. In this case, we have a script on the right side that takes some information and creates a bar graph for us. So applications of machine learning in cyber: recognizing threats, finding patterns, reviewing code. There's a robust conversation going on in the chat I just saw about that sort of thing. Risk identification, assessment, remediation, pretty much everything you possibly want to do, we're harnessing machine learning today to do. And that's to find these sorts of attack scenarios. This is just four pretty vanilla examples, but they're important ones. For every file sent through a network, is there malware in there? Setting up systems that sniff through code as it goes through our network to see if there's anything inside of it. For logon attempts, has someone's password been compromised? A very basic but very important function. Happens, I'm sure every one of us has probably logged into a system one way or the other a dozen times today, if not more. Very important to keeping ourselves secure and safe. For every email received, is it a phishing attempt? For every request to your servers, is it a denial of service attack that's going to bring your server down? These are 4 very simple questions, but they're very bedrock questions to keeping us safe on a regular basis. And so one of the things that's interesting in cyber is also sort of reverse engineering malware, doing malware analysis. If we find software that's doing something bad, how do we know what it's doing? How do we find out where it's from? How do we harness it to use it as a tool for something else? So we use things like fuzzy matching, automatic selection, adaptive responses, a variety of different machine learning tools to help us actually analyze software without actually having to run it, or to run it safely so we can figure out what it does. And that's my hour on cybersecurity as big data. Hopefully that was interesting. I know we have a bunch of questions. I'm happy to talk some more, and I guess we throw open the floor, Tiffany.
Yeah. Thank you so much, Joseph. That was so illuminating. I know there are tons of questions in the chat, so if I missed a few here and there, please forgive me. If you want to ask any additional questions, please throw them in the chat or the Q&A now, and we'll walk through a few. One, Giselle says, in visualizing malware networks using graphs and visualizations, how do we solve the distortion problem, or is there an algorithm to solve that?
Well, that's a really good question. So to back that up a little bit, the distortion problem, just to make sure we're on the same page, is the idea that there's no such thing as a perfect visualization. Okay, and so depending on, and I'm going to use the term level of abstraction, how detailed you're looking at something, you're always going to lose some piece of information. Okay, for you audiophiles out there, for example, if you've got an old vinyl or a new vinyl, actually, I'm cutting new vinyls nowadays. I mean, at this place in Chicago,
I have a ton of new vinyl, yeah.
And that's analog audio, and that's the best audio you can really ever listen to, right? And if you listen to a really high fidelity digital track, you're probably not going to tell with the human ear. Some people say they can, but a really good one, it's going to sound great. But like on Spotify, it's not the same. It's not the same at all. But it's good enough, But you're throwing away a ton of data when you're listening to that Spotify track as opposed to that classic vinyl track or a magnetic track. It's the same thing visually. When you try to put something into a graph, you're going to throw some pieces of information away. The best way to solve that is the ability to zoom in and zoom out on data in order to get higher or lower fidelity depending on the need. A lot of these questions, the question like that is oftentimes very, very situation specific. So.
Got it. Tunde asks, are there protections against flooding SIEMs with junk data to mask a breach? Something to buffer overflow?
Sure, there are certainly protections to that. The thing is that what we really try to do is to think like the bad guys. Traditional detectives, cops, police officers try to do that too. Because if we think like a person that is normally following the rules, we're probably going to be blind to what the bad guys do. If you can put yourself in the mindset of what is a bad guy going to do to try to take advantage of something, then you can guess, make educated guesses on what they're going to try to do next. And although there's plenty of automated systems for what you're talking about, I would answer that the best way to hedge against that sort of an attack is to predict where that attack is going to come from based on how bad guys think. And we spend a lot of time thinking about that.
Awesome. In the Q&A, someone says, do Internet of Things or IoT and Edge create enough data to break well-established SIM patterns?
That's a good question. No, at this point, we have enough capacity to keep on top of the problem, and the capacity builds every day. So I would simply say that for the most part, new devices are not outstripping our capacity to stay on top of the problem.
Got it. Rami asked, what are some of the most important cybersecurity modules in Python that you would recommend playing around with beyond pandas, scikit, and TF that are used for machine learning?
Those, sounds like you know a lot. The thing about it is so you just listed great ones. So that's a great start right there. It's going to depend on the area of cyber you really want to be in. That's the thing. As I showed you on that life cycle of a particular incident, there can be different packages and different tools for different threats and different vulnerabilities. What we try to do, and we spend, in a 15-week course, if you were to join us, every day we do 2 lectures a day on at least one deep dive of a topic. So that's twice a day. So if there's 5 days a week times 15, that's 75 days times 2, that's 150 lectures plus 150 labs. So 300 different ways of grappling with all sorts of different technologies. Having said that, we spend a lot of time not on the technology, but on the ideas. The most important thing here is not what someone's particular personal favorite is today, because that's going to change tomorrow. There's going to be a new thing next week. Things are constantly moving. So the thing to do is that if you look at these ideas, they're the same things that there were 20 years ago. They just have newer ways of dealing with it. These sorts of systems like the SOC and cyber ranges and all of this, SIEMs, robust SIEMs, were barely a thing 20 years ago, even 10 years ago. Now we have these new tools, but the problems are exactly the same. So it's important to stay on top of the concepts, because you're always going to get new tools and they're always going to change. So don't get too focused on one particular technology. Keep your mind open to constantly learning, which is probably one of the most important things that we spend a lot of time on, is being a lifelong learner, which anybody that is, approaching this sort of a boot camp type of environment, you're already in that mindset.
Got it. Some more questions are coming in. Given Flatiron separate cybersecurity engineering and machine learning, what track follows this lecture?
Which of cybersecurity?
Yeah.
There's overlap for all of these, and I think you find in any particular career that very few people stay in one thing, especially nowadays, for forever. Even 5 years is a long time, and you find other things. Or even if you come in as an analyst, then you become a supervisor, then you become a manager, or maybe you become an executive. There's all sorts of different places to go. But yeah, definitely cyber is where I would aim you from here.
Got it. We have a question in the Q&A that said, what are the minimum core competencies required for a newer cybersecurity analyst, like someone who's just getting started?
Okay. So they essentially track with the 8 topics of that we go through at different depths throughout our program. So, and I'll probably forget 1 or 2, but cryptography, okay, at its core, cryptography is very important. It's the math that underlies how we keep things secret, passwords and all of that sort of stuff, but crypto. Then there's network security, which is clearly the stuff that connects all of our toys and tools. Application security, that's how to keep software secure. Systems security, that's hardware, okay, servers, routers, PCs, phones, anything that's hard. threat intelligence, I'm on 5. GRC, governance, risk, and compliance. And I knew I'd forget a couple. I'm close to that. I forgot one more. So, but that's about it. So basically, networks, applications, software, math, GRC, threat intelligence, and something else.
Gotcha. Let me see. There was a good one. Daryl asked, will the introduction of quantum computer be a benefit or a detriment on cybersecurity defense?
Good question. And I forgot, I remember what number 8 was. SIEMs. The 8th topic is all about what I was just talking about for the last hour. That's the one that brings all those other pieces together. Anyway, quantum computing, still, in development. For those of you who aren't nerdy enough to know what that means, it's a whole other level of computing power beyond anything that anybody understands or uses today. So revolutionary that, kind of like cold fusion, if it ever comes to exist, I think it's going to be such a game changer that I'm not the kind of person that could possibly predict the future on that one. So.
Got it. In the chat, in the Q&A, it says, what is the difference between threat intelligence / threat hunters versus vulnerability analysts versus SOC analysts within cyber?
There's a lot of overlap. The thing about it is that, there is, cybersecurity in and of itself is a really, really new discipline. Okay. And people come to it from all sorts of different angles, and there's all sorts of different needs, as those topics just illustrate. And so there isn't one particular set of sort of standard job titles and that sort of thing. So I've seen different employers with different job postings with the same job title looking for completely different things. So the best thing to do is really, in this sort of world where things are constantly changing, is, again, not to focus on a technology or one bag of tools. Your best tool is to be open-minded, broad, and able to change and grow. And that's what we focus on throughout our entire program. So yeah, you learn a ton of stuff over 300 different points of contact, but through that experience, what you're really getting on top of just the nuts and bolts is I'm gonna have to keep on top of this stuff moving forward.
Got it. That's pretty much all the questions that, as I said that, someone asked another one. After completing cybersecurity training, is a portfolio necessary, or is having a certification good enough? Good question.
Well, so those are two different things, and it's going to depend on your employer, okay, or your potential employer. And people out in the field have vociferous arguments about this exact question. There's actually two questions in that question. You're asking about whether there's a portfolio is important, and you're asking about whether a certification is important. So let's back that up a little bit. Our design folks, for example, have a portfolio that they produce through a variety of different projects, because they're expected to be able to show, hey, I created a web page or a web application. Here's how it works. Same thing with the software people. The cybersecurity folks, we don't have a portfolio, because cybersecurity analysis and engineering is really more about looking and communicating. Okay, we do write a bunch of reports. So if you didn't like writing in college or in high school, don't worry, it's not too bad. But we have 3 or 4 reports you have to write, because one of the cornerstones of a good cybersecurity analyst is not technology, but communication. Okay, is being able to not just detect and find the problem and stop the problem, but then to be able to communicate that in clear language to others so they understand the importance of it. So we don't have a portfolio. For those of you who don't know what certifications are in the IT world, Every branch of IT has a variety of different courses and certification tests you can take so that you can put certain things on your resume to show that you have a certain level of competence in whatever area. And there's a variety of different cybersecurity certifications. We generally, our program doesn't mirror but tracks loosely the Security Plus certification with a lot of extra stuff. You should be pretty close to ready to take the Security Plus exam once you're done with our program with a little bit of extra study. That's true for any of those sort of high stakes tests. But I've had literally the guy who used to run IBM's cybersecurity branch lecture a class of mine, and somebody asked this question. This is the guy, 20 years of cybersecurity, the guy who created these cyber ranges, this whole concept. His name is Caleb Barlow. What do you think about certifications? Couldn't care less. And his thing, not that they weren't important, but they weren't a major driver in making a decision about hiring someone, because what they hire for in IBM is communication and creativity and drive and teamwork and all of that stuff. Because the technical stuff, yeah, it's important, but if you can't communicate about it, if you can't work with others about it, if you can't, make decisions about what's important and what's not so important, those are the sort of, it all boils down from that perspective to judgment. Can you come to an employer and say, you can trust me with the crown jewels, you can trust me with your grandmother's photographs, you can trust me with your whatever's important to you, you can trust me, because that's what cybersecurity is about.
And just a quick question about the certifications. We have a question saying, is the Security Plus certification enough to get into entry-level cybersecurity jobs?
See, again, when you say enough, nobody gets a certification and then, okay, here's your job. Okay.
Gotcha.
It doesn't work that way. It's going to be dependent on every different employer. Okay. There might be some employers. So again, I just had that example of Caleb, not a determinative factor on that guy's radar at all. Okay. But for another company, another hiring partner, another decision maker, they might think that certifications are huge. Again, it might be that a more technical job where knowing a lot of the nerdy stuff is really super important, maybe that would be a determinative factor. But a lot of times people do ask these, and these are reasonable questions when you're getting started out. I would be answering these questions too. There is no silver bullet. There's no silver bullet. It's in cyber, it's really more about curiosity and constant learning and communication and wanting to help people keep their stuff safe than any one particular tool or ticket.
Got it. Carl asked, do any SIEMs review more hidden channels of activity, such as RAM changes or EM emissions, or only things humans usually review?
Good question. Yes. So all of them do some of that to some degree. Okay. So there's packet analysis. What does that mean? Packet analysis means actually looking as something is traveling through the network in real time and looking at a packet and seeing if there's any code embedded in it and what does that code match up to, or what is it part of. There are other systems that do broader sweeps of software to detect problems that people can't easily see themselves. All of these SIEMs are very modular, where you have a base package and then you plug in other stuff depending on what you're trying to analyze over the course of time. And your particular install may well be different from time to time. It may be different across an enterprise like IBM, where they're global. One cyber range may be set up one way, another one may be set up another way. Very, very flexible. So the short answer is all of them are capable of those sorts of activities and facilities. The question is are they set up because of the imperatives of that particular organization?
Got it. Do you teach Suricata and Zeek?
In our particular current curriculum, I do not think we have those plugged in at this point.
Got it. What do you think is the 80/20 on being cyber secure on a personal decisions level, besides strong and somewhat varied passwords and MFA?
When you say the 80/20, can you clarify that?
Yeah, Rami, you can, if you are still around, you can pop that into the Q&A and we can get back to it.
I can extrapolate from there. Unfortunately, I'm gonna hold off on personal advice on how to keep yourself. There's this thing out there called the internet. You can Google that and make some decisions on your own.
Gotcha. Is there a demand for project managers in cybersecurity?
Oh yeah, absolutely, sure. So, which gives me the leaping off point to talk about transferable skills. Assuming if you've asking that question, you've either studied project management, or you are interested in it, or you have experience in it. Right now, I have a group of students who are about 15 years, or not 15 years, about 15 people. People from finance, people from banking, one kid straight out of high school, 18 years old, another person from compliance. If you have project management, what we're talking about here is project management. I mean, a SIEM in and of itself is basically a computerized project management software on steroids. So yeah, there's no end of need for project managers in IT generally, but also in cyber. So yeah, go nuts.
Awesome. Well, thank you so much, Joseph, for answering so many of these wonderful questions. They were really in depth, and for giving the lecture for today. We greatly appreciate you. For all of those of you who stayed on the whole time, we will be emailing out the recording of this event, as well as the deck that Joseph presented. And we just want to say thank you. We know you could be spending your time anywhere. You spent it with us, and we hope to see some of you in our program, or just help to facilitate you continuing to learn and explore in cybersecurity. You all have a great evening, and cheers. Bye.
Thank you all.